particle B or particle 2, I'll write it. Or B will write it. So it is moving in circular path. So angular velocity and the radius vector is RB, and the other particle. So let me bring in different things. So both are in same sense. Let both move in a same sense. And this position vector, let it be RA. Now we have to calculate angular velocity of A with respect to B. I think you can directly bring the, just know what I used that particular formula, what happened, you can apply it here, no? Two particles are moving in circular paths, respective circular paths, with the angular velocity omega A and omega B respectively. Find omega AB. Okay, now they are not in the same path, no, in different circles. So what is the angular velocity of one, like a particle with respect to the other particle? So I think I'll stick on to the basic thing just now we had, no? So here there's a line joining them. That's all, no? So what is the method? So draw a line joining the particles, let it be. So now get the velocity vector. So component of velocity directed along that. So this will be theta, let's assume. This is theta, 90 minus theta. This will be okay, fine. Yeah. No, this should be theta, no? What is VA? So the VA is like this. VA is RA omega A. VB is RB omega B. We know only omega A, omega B. Just I brought VA and VB so that you can easily understand. So this is line joining them. So I'll call that as S. Or you are familiar with L, no? Let me bring L, no problem. That is. Now angular velocity of A with respect to B. So what you should do now, angular velocity of A. Look at the sense. Both. I say here you show it. This is omega A. Okay, all of you. Both are in same sense. No, look at the angular velocity of both. Both are in same sense. No. What is the definition? What it says? Component of velocity is directed perpendicular to line joining A and B. But we didn't brought any component of velocity for B, no? What is the mathematics we should take here? I'll extend that red color dotted line. You see this and okay, come for this. So again, so a line normal to that. Not perpendicular. Oh. You see that one. Okay, this should be theta. Will I agree? This should be theta. No, what are the no need to write many equations. Just look at that one. Component of velocity. VA is like this. Component of velocity perpendicular to the line joining AB. Which component will come? V cos theta or VA sin theta? VA is VA cos theta. Similarly here, VB sin theta. Fine. So they should be equal to VA cos theta, VA cos theta minus of minus VB sine theta by that L. Let it be here. Now what is VA? VA should be equal to RA omega A. Cos theta, anything can you write it from the diagram? RB by L plus VB. VB is what? RB omega B. Sine theta, you can write it as sine theta is cos theta is RA by L, no? Yeah. This will be RB by L. Let it be, this is equal to, so omega A plus omega B RA square omega RB square omega B by L square. What is L square should be equal to from the triangle? So therefore this omega.
Sir, it's not L square.
Should come, no?
Correct only, sir.
Correct only, sir.
Okay, final answer will be. I think what I gave that earlier, the one problem, no, that is the base, no. With that, you can manage any of the thing. So what is the direction of omega AB? It will be same thing again. So where you have to show omega AB? Here you have to show it. I'll bring the red color. Here you have to show it. Then not at O. You should not show at O. I'm making clear. You have to show it here. Angular velocity of A with respect to B, that vector will be out of the plane passing through point B. And in the sense of omega A and omega B only. Now you do the same problem for opposite sense. I'll go for next concept. Can you work out opposite sense? You change VB in upward. Here I took in same sense, no? Both are. So you take the VB in this direction and work out here. You try that one. Okay, all of you got this. So if the particles revolve in different circles, then can you find out angular velocity of one with respect to other? The same basic formula. What is the first thing you have to calculate? The distance, the separation between the particles A and B, that should be calculated. And here I took some simple case. You may give any arbitrary case here, where you have to bring the concept of circles. Okay, got this? That mathematics is what will come into picture. You have to be alert. Okay, now this about the particles like this, we brought it. So let's take the next example. No, you can see this question. Particle A approaches the center C of a rotating disk. If V equal to R omega, find the velocity and acceleration of B relative to A as the function of the time before the particle